Hello, my name is Greg Webb, Park and Natural Resource Manager. On behalf of the U.S. Army Corps of Engineers, I'd like to welcome you to Bonneville Lock and Dam. Today, myself and the team here at Bonneville will be doing a virtual tour, trying to give you a snapshot of all the different things we do here. We'll talk a little bit about the multiple missions, which are hydropower, navigation, recreation, and environmental stewardship, as well as fish passage.
Before we get started, let's take a moment to orient ourselves on where Bonneville is within the Columbia River Basin. The Columbia River originates in the Canadian province of British Columbia, and from there spans through most of Idaho, Oregon, and Washington, as well as parts of western Montana and small portions of Nevada, Utah, and Wyoming. The basin, at 258,000 square miles, is roughly the size of Texas. About 145 miles upstream from the Pacific Ocean sits Bonneville. And further east, you'll find two other Columbia River dams, the Dalles and John Day. These three projects are part of the Portland District. Farther upstream, we have the McNary Dam, as well as Ice Harbor, Lower Monumental, Little Goose, and Lower Granite projects, all of which are situated on the Snake River, the largest tributary of the Columbia. On this route, commercial barge traffic can make their way to and from Lewiston, Idaho, a port situated 465 miles inland from the Pacific. Now that we have a better understanding of where we are located within the basin, let's take a look at what encompasses Bonneville Lock and Dam. We started out with Greg showing us the auditorium building, which is part of Bonneville's National Historic District. In 1987, the auditorium, with 6 other original construction components, and the surrounding grounds and landscapes were named a National Historic Landmark. As we move across project, we first come to the new navigation lock, built 1986 to 1993. The new structure was 75 feet longer and 10 feet wider than the original, and constructed to match the size of locks further upstream. We have the original Powerhouse, or Powerhouse 1, which was constructed from 1933 to 1938. Then we have the spillway, which originally functioned as an overflow valve. When we had excess water and lacked the electrical demand, it was routed through the spillway. Now we also utilize it as a way to pass juvenile salmon, or fingerlings, downriver. April through August, you will see water cascading through its 18 bulkhead gates. The second powerhouse was added from 1972 to 1982. What now could be mistaken as the naturally occurring channel of the Columbia was originally mainland Washington. The construction of Powerhouse 2 required the Corps to excavate through the town of North Bonneville, as well as the existing state highway and railroad. Upon completion, the 8 additional generators essentially doubled Bonneville's power output.
We are making a stop at Bonneville's second navigation lock, constructed between 1986 and 1993. Pretty amazing engineering feat. Essentially, it was Oregon Shore mainland. We had to carve through the basalt rock in this region, shift the highway, shift the railroad to allow us to build a bigger lock that matches the locks of the dams that were built later upstream. So this one's 10 feet wider, 175 feet longer than the original lock. We have a 60-foot lift. Barge traffic typically passes here between 8 and 10 times a day. Small amount of recreational traffic as well. 60-foot single lift lock, miter gates on both the upstream and the downstream. And then there are floating mooring bits that ride up and down in channels along the lock wall that the barges or recreational craft will tie to. We are now at historic Powerhouse 1. Let's go inside and take a look. Originally constructed in 1938, Powerhouse 1 was part of Roosevelt's New Deal to bring electricity to the Pacific Northwest. Take a look downstream at the Powerhouse Gallery and you can see 10 generators today. When it was first constructed, we started out with 2 generators and 4 empty bays. World War II rolled around and the demand for electricity greatly increased. So those 4 bays were filled and an additional 4 more were built and added to bring us up to the 10 today. One unit that you can't see is below deck, which is Unit O, which gives us station service power here on site. Okay, we are in the Powerhouse 1 Visitor Gallery, taking a quick look at one of our older cross-sections of Powerhouse 1. Again, we had about a 60-foot difference in the level of the water here. Water's channeled down, Kaplan turbine setup. Scroll case here, water pours around it, goes through wicket gates. Between that and variable pitch on the blades, we're able to control the water flow to get the correct RPMs. Rotor and stator up here. Transformers are on the upstream side. Powerhouse 1 is kind of unique. It started out with a switch yard up on top. There's a review going on now that switch yard may be significantly modified or go away. 2 primary lines coming out, one into Washington, one into Oregon, 115,000 or 230,000 volts. Combined with the Oregon and Washington sides, we generate about 1 million kilowatts of power, which is enough to supply an area about the size of Portland and Vancouver with electricity. Again, it's part of that balancing act: water for navigation, water in the river for recreation, water for fish passage, and that power component as well. Okay, we're making a stop at the Bradford Island Fish Ladder. We're actually starting at the upstream or the exit end of it. And this one has 2 branches. One branch comes here from the Powerhouse. The other one comes from over at the spillway. They come together and run right past the visitor center here. A couple interesting things to see at the exit are a lamprey flume, which is a newer fish passage element for us. And lamprey are an eel-like fish that migrate as well. Their passage requirements differ from salmon. So these sluiceways, or boxes essentially, that look almost like air duct, have a thin sheen of water that runs across the surface, and those lead from an area that would essentially be a dead end. It's an auxiliary water section of the fish ladder. Lamprey are attracted, similar to salmon, to that fast-moving water. We're able to screen the salmon out of that section, but the lamprey can work their way through the grading, and as they move upstream, now what they can do is get into these sluice boxes that allow them to propel themselves up. They've got a suction cup mouth, so they will latch on as they would navigating up a river to hold fast in the current, and they'll continue to work their way upstream. On the salmon portion of the ladder, we have a zigzag section. If you look at it from above, kind of looks similar to a maze. What that is that's a flow control section. It allows us, even though we're running the river dam that has a fairly consistent pool level, there is a pool or reservoir level, there is a little bit of fluctuation, and were we to have a standard weir-based ladder up at this end, we would have to raise and lower weirs as that fluctuates. So this maze or flow control section zigzags back and forth, gives the salmon a constant line of current to swim against to migrate their way out the ladder. Once they get up above us, They may go to a local stream here in the fall, or if it's a spring migrant, they will typically go maybe as far as 1,000 miles upstream to find their home stream. Working downstream on the ladder, we come down, we hit a big flat area up above the upper weir, and there is a black screen that funnels or narrows down to go past the fish count window. We have observation windows for the public in our flow control section, and right in that transition that's where there are fish count windows. And there are two count stations, one on the Oregon side, one on the Washington side. Those counts are combined to tell the region how the fish passage is for any particular year. As they funnel through there, it's a person. It's not done electronically. We've got to be able to discern between the different species that are migrating through. And as they move forward and back, they will add and subtract for the number of fish that are moving through. Moving further downstream, we see the steps or weirs that make up the what you think of as a traditional fish ladder. To give you an idea, those walls are about 6 feet high, about a foot or so of water pouring over the top of that. And originally the walls were solid. Salmon would have to jump up the ladder. Now typically we don't see salmon jumping up the ladder because there have been holes or access passages cut into the weirs that allow the salmon to work up without having to jump clear out of the water. It takes about a day for them to locate the ladder, roughly up to a day to move up through the ladder, but they can do it in as little as an hour as well. The controlled river flows about 4 to 6 miles an hour. The flow in the ladder is slightly higher than that to give the fish a signal as to where to go. It's about 5 to 7 miles an hour, and of course both those water speeds are much less than the free-flowing river would have been prior to construction of the dam.
Making our way across project to the Washington side, we come to Powerhouse 2. Here's a cross diagram looking into one of the 8 units. Again, we see that the water from the pool above drops down 60 feet into the turbine pit, which entered Powerhouse 2 through one of 3 bays. The scroll case guides the water into the wicket gate openings. Those wicket gates are adjustable fixtures that control how much water flows over the turbine blades. As water crashes over the variable pitch clapping blades, the force of the water's energy sets the turbine in motion. The main shaft connects the turbine to the generator above. Inside the generator is a rotor, which is a rotating set of electromagnets. Around the outside of the rotor are stators, coils of copper strands that, when energized by the moving magnets, create electricity. Bus ducts extending from the generator contain copper bars which carry electricity out of the unit into the transformers outside. Once the electricity leaves the transformer onto the power lines, the Bonneville Power Administration takes over the transmission and marketing of the electricity.
We are currently in the second powerhouse overlooking the generator area from our display gallery. When visitors come on site, they can get to this without a special guided tour, so this is a great spot to overview the Powerhouse. 8 units on this side, roughly about the same in output as the Oregon side. Powerhouse 2 has priority fish passage wise, so we tend to operate more generators on this side during key fish passage season than we do over on the Oregon side. Powerhouse 2 was developed with the original intention of handling peaking demands in the Pacific Northwest, both in the fall and winter, and then in the mornings and evenings there are increases in the demand for power. One of the nice benefits about hydropower, as you probably know, is we can manipulate that easily just by allowing water in and out of the various generators. We talked a little bit about the changes in manipulating the spillway that causes us to operate that structure differently. That's true of the powerhouses as well. We tend to operate from the outside in as far as units. So that means the end units at each end of the powerhouse are operated more continuously, and the interior ones, based on demand, would be the ones turned on and off more frequently, which changes the wear and tear, and that is something that our maintenance folks evaluate. Maintenance of the units is on a staggered system, depending on the powerhouse, between 3 and 5 years. They will alternate a certain number of units each year for maintenance. We are down on top of Unit 17 in Powerhouse 2. If you were on an actual tour with us, you'd feel a lot of vibrations. That's 624 tons of water a second traveling through this unit. If we took an average Olympic-sized pool and poured it through our generator, it would run it for about 4 seconds. It's 3-phase, 60-cycle electricity that we're producing down here. All right, so we've dropped down to the next level on the generator, which is in the turbine pit. So through here we can see the shaft that connects the turbine blades to the rotor and stator up above, and in just a couple minutes we'll get you a shot of the wicket gates. There's 24 wicket gates. Again, work sort of like vertical window blinds. There's a staving portion that is static, and then an adjustable wicket gate itself. That helps channel the water into and over the top of the turbine to get us spinning the correct number of revolutions per minute. We are over at the Washington Shore Visitor Center complex, checking out the underwater windows that look into the fish ladder. We're here at the tail end of September, which is an excellent time of year. Actually, the first 2 weeks in September is normally the peak of our salmon run. So we've got lots of action in the fish ladder. Some Chinook salmon, coho salmon, and steelhead moving through right now. Sockeye a little earlier in the year. Shad, which are a non-native species, come through earlier in the year. And then another species that is a lamprey. Looks similar to an eel, but actually a fish. Those migrate through. We talked a little bit about their passage routes and the differences earlier. I'm at the opposite end of the building. Downstream of us, we've got the fish counter window. That's the spot that the passage route is narrowed down so that the fish counters can see all the different fish that are coming through. This is that flow control section again that is a little bit wider. So these fish have almost made their way to the fishway exit and will be heading on upstream. We've made a stop here at Fort Cascades National Historic Site, which is An excellent location that kind of converges the recreation program with the cultural and natural resource management programs. This is a 1.5-mile interpretive trail that highlights the tribal activities that were here, early travelers on the Oregon Trail, fish wheel and fish transportation that happened in the area, portage around the Cascade Rapids, and brings us on up to today. So much like the visitors that came here before the dam, the Army came here before the Army Corps of Engineers did, and they were engaged in protecting the portage route through the area here. We've made a stop here at one of the key areas of Fort Cascades. Park ranger staff are involved in monitoring and checking on 25 sites on core lands, cultural resource sites. I'm standing next to a petroglyph replica, which is one of the areas where visitors can get a glimpse of the cultural and historic sites at Bonneville. There are multiple groups that we cooperate with along the Columbia River, area tribes, federal agencies, and state agencies to protect, enhance, and interpret significant cultural resource sites in the Columbia River Gorge. We'd like to take a little bit of time to talk about the Recreation and Natural Resource Program. Bonneville gets about 1 million visitors each year. The majority of them come through our visitor centers, but we have 6 recreation areas scattered around that are utilized heavily as well. On our pool, we see about 2 million visitors, with key highlights being world-class windsurfing, kiteboarding, paddleboarding, and fishing. Bonneville has a significant impact to the tourism economy in the region. We cooperate with other interagency partners, local communities, tourism organizations. We get traffic from cruise ships, bus tours, people out hiking, boating, and they all utilize the local community. On behalf of the U.S. Army Corps of Engineers, I'd like to thank you for coming on the virtual tour today. Hopefully you understand a little bit more about the balancing act involved with hydropower, navigation, fish passage, recreation, and environmental stewardship. We're looking forward to the time that you can come out and visit with us on site at one of our visitor center facilities. Until then, thanks, be safe, pack it in, pack it out.